for today. First, we'll see what are classes and objects in general. And then we'll see what are classes in Python. We'll learn how to create a class, what is its syntax, all those things. Then we'll see what exactly is inheritance. And then finally, I'll tell you what are abstract classes. So now I'll move forward and we'll see what are classes and objects. So before I explain you classes and objects, I'll tell you Python is an object-oriented language, but it is not completely object-oriented. It has certain procedural functions as well. Now let us understand what exactly are classes and objects. So what are classes and objects? Basically, classes allow us to logically group our data and function in a way that is easy to reuse and way to build upon if need to be. Let me explain you this with an example. So we have a class here that is employee, and it has various attributes such as name, age, and salary. But what are objects? Objects are nothing but the instance of this particular class that is employee. I'm just giving an example. So what are objects? Objects are the instance of a class, and in our example the class is employee. So the objects will be instance of the employee class. For example, this is the first object that contains variables such as Sarah, the name, 37 is her age, and this is her salary. Similarly, we have the second object or the second instance where the name is Neil. When we talk about his age, it is 43, and this is his salary. And similarly, we have one more object, Jessica, age is 26, and this is her salary. So we'll move forward and we'll see how to actually create a class in Python. So this slide actually tells you how to create class in Python. So I've given a syntax over here in which you have to first write class, then give a name, and then various variables and functions that you are going to define in your class. Now class in Python actually consists of three key components. There's a class variable, and this class variable is actually shared by all the instances or the objects of the class. Now when we talk about instance variables, these variables are unique to each and every object or class. Finally, when we talk about method, method is nothing but a function that we define inside a class. So I hope we all are clear with what are the components of a class. So we'll move forward and I'll tell you practically how to create a class in Python. So this is my PyCharm, guys. So over here I'm going to create a class. So before I go ahead and create classes, let me tell you the classes basically consist of data and functions. So I'm going to call data as attributes and functions as methods. So I'll be using both of these terms quite often, so don't get confused. When I talk about attributes, it is actually data, and when I talk about methods, those are actually functions. So I'll go ahead and I'll create a class. I'll name it as student. And now I'm going to keep it as empty, so I'll just write the pass statement. So now you can see that I've given no attributes and no methods. So what I'm going to do now, I am going to create two objects of this class that is student. So in order to do that, I'll type the name of those objects or the instance. So I'll type std_1 equal to, and the name of the class, that is student, and parentheses. Now I'm going to declare one more object and I'm going to name it as std_2 equal to, again, the name of the class and open and close parentheses. So now what we need to do is we need to define the instance variables. And I've told you earlier as well, what are instance variables? Instance variables are nothing but the variables that are unique for each and every instance or an object. So let me show you how to do that. I am going to type first the name of the instance, that is std_1. Suppose if I want the first name of the student, so I'll just type dot first equal to, give the name, so I'll just type in Neil. Now I'm going to define the second instance variable for the same instance or the same object. So for that I'll type std_1, and now I want the last name equal to, you can say, Verma. Now I want to add one more instance variable, that is his email ID. Email equal to neil@school.com. And now finally I'm going to write his percentage or the aggregate marks that he scored. So again, student_1 dot marks equal to Say if he scores say 55. Alright, let's keep it 55. So I have defined 4 instance variables. First is the first name, then comes the last name, then I talk about email, and then finally marks. So now what I'm going to do is I'm going to use the second instance and I'm going to define certain instance variable for that instance. That is std_2. So let us go ahead with that. std_2 dot first equal to Hemant. Now I'm going to define his last name. So for that I'll type std_last Sharma, and now his email address hemant@school.com, and finally his marks. Okay, so let us make him studious and give him good marks. I'm going to give him around 90%, and yeah, let us keep it this way. Now what if I want to print the email address of both of these students? So for that what I need to do is I need to type in print std_1, and I only want the email address, so I'll just type email. Similarly, I'm going to do it for the second object or the second instance as well. So I'm going to type in print student2 dot email, and now let us go ahead and run this. So as you can see, it has printed neil@school.com and hemant@school.com, which are nothing but the email ID for the 2 instances that I've created. Now similarly, you can type in the first name as well. Let me just show you. Here also you type in first. Go ahead, execute this. Alright, so Neil and Hemant. Now what if I don't want to manually set these variables? You can see that it is a lot of code and also it is prone to error. Now to make it automatic, what I'll use the init method, or you can say the init function. I'm going to define it inside my class. So you can think of initialize method, or you can consider this as constructors if you're coming from another programming language background like C, C++ or Java. Now when we set a method inside a class, they receive instance automatically. Let us go ahead and accept the first name and the last name and marks. So for that what I need to do is I need to type in here, let me first remove this pass statement, and now I'm going to write the initialize method. So for that I'll type init self. Now I'm going to write in various attributes, or you can say the various instance variables that I want. So first I want the first name, then I want the last name, then I want marks. Alright, looks fine. So now basically what is self? Self is nothing but an instance. What I mean by that is that whenever we write self.first, let me just show you, self.first equal to first. Alright, so whenever we write self.first equals to first, it's same as writing std_1.first equals to Neil, or std_2 first is equals to Hemant. So I hope you have understood why I'm doing this. So except now doing it manually, it will be done automatically. You can actually change this name as F name as well, but I would like to keep it this way. Alright, so go ahead and type the other variables as well, self.last name. Alright, let me just give certain spaces, and the last name, let's just last, and then type in self.marks equal to marks. Now for email address, I'm going to type in self.email, and now what I'm going to do is I'm going to first write the first name plus, let us put a dot between the first name and last name, so I'll just put in a dot and then add the last name plus, if I want, now I'm going to write in @school.com. Alright, looks fine. And now what I'm going to do is I am going to type in here student and the first name of the first student, that is Neil. Now what is the last name? Keep it as Verma. Now, so marks will be around 60. Now second student is pretty studious. His name is Hemant. Surname is Sharma. And say his average marks, you can say it as 90. I've never scored 90% in my entire life. All right, so jokes apart. So now what I'm going to do is I'm going to print the first name of both of these students. So let us see if that happens. Run classes and objects. All right, so you can see that Neil and Hemant is printed. So now what we have done, we have created the instances of student class. And now we are passing the values specified in the init method. So now our init method takes the instance which we call self and the first name, last name and marks as arguments. But when we have created the student down here, these instances are passed automatically. So we can leave off self and we only need to provide the first name, last name and marks. So with this self, what actually happens, the init method will run automatically. So std_1 will be passed as self and then it will set all these attributes that are first name, last name, etc. It will set self.first equals to first, which we have passed as Hemant or Neil. Similarly, last, marks, etc. Let me give you one more example. Now this time we are going to print the email for both of the students. Go ahead and execute this. Yep. So neil.varma@school.com and hemant.sharma@school.com. Now suppose we want the ability to perform some kind of action. So to do that, I'll add some methods to this class. Suppose I want the ability to display the full name of the student. So one way of doing that is what I can do. Over here, I can print one more line and put in two curly braces. That is the two placeholders, I should say. Give a space between both of them. Dot format. And the first instance, that is std_1 dot first comma std_1 dot last. That's it. Go ahead and print this. So it says Neil Verma. So we have actually added, so this is nothing but the concatenation of two strings that you can say, the first name and the last name. But again, I don't want to do this for all of my instances. So why not create a method inside a class that allows us to put this functionality in one place? How about that, guys? All right, so I hope you guys are enjoying. I love playing with PyCharm, guys. So yeah, let's just see what we can do with it. Now I'm going to define one more class, full name. Now, as I've told you earlier as well, each method inside a class automatically take the instance as the first argument. For example, std_1 is an instance, std_2 is an instance. And we are going to always call that self. An instance is the only argument that we need for full name, right? We have first name, we have last name. So we need just the instance. Self, all right, give a colon. Now within this method, I am going to take the same logic that is present here. And I'm going to write here as return. Now instead of std_1.first and std_1.last, I'm going to use self so that it works for all the instances. Currently it will work only for std_1. So let us just go ahead and type in self. All right, looks cool. So now let us just remove this part. All right, sorry for the typo, guys. Let's just keep it as self. All right, so now let us just remove this part. And over here, what I'm going to type in, I'm going to type in std_1 dot full name. Notice that we need parentheses here because this is a method instead of an attribute. If I don't put the parentheses, it will return the method instead of the return value. Now let us just print this for the second student as well, who is the cream of the school. All right, so let us just go ahead and run it. Cool, so we have got Neil Verma as well as Hemant Sharma as the full name. So instead of typing this out for each full name, now I can use that method. Now let us talk about class variables. As we have discussed in the slides as well, we have seen what are instance variables, we have seen methods. Now the thing that is left is class variables. Now class variables are variables that are shared among all instances of a class. Our instance variables can be unique for each instance, like names, marks, email ID, etc. But class variables should be same for each instance. So in this example, what kind of data that we want to share between our objects? So in order to declare a class variable, just below the class, you need to write the name of that variable. I'll write it as pers underscore rise and equal to, so suppose it increases by 5%. So yeah, let us just type in as 1.05. Although I know it is not general for everyone, there are certain students, for example, Neil in this case, who might not study properly, or so there are different kind of students, but I'm just giving a general idea. Don't just go inside the example too much. Just understand the concepts here, guys. All right, so percentage rise is 1.05 for each and every student. Let's just think it that way. All right, so what I've done here is I have defined a class variable that is percentage rise, and that is equals to 5%. So basically every student is getting a 5% rise in his or her marks every year. So I need to write a method for that. So what I'm going to do is I am going to define one more method, and I'm going to name it as apply underscore raise. Now again, I'm going to type in as self, because each instance is passed, that is std underscore 1 or std underscore 2. So we need that instance argument that is nothing but self. So I've repeated that quite a lot of times, so I'm not going to say that again. So now over here, I'm going to type in the logic, that is self dot marks equal to int, that is the data type, self dot marks multiplied by 1.05. All right. So it looks perfect to me now. So now what I'm going to do is I am going to edit this print statement, and for this student underscore 1, I'm going to write in here marks, and then over here, now I'm going to write one more print statement, and I'm going to type in here student underscore 1 dot marks, and then now I'm going to write, so now we have printed out marks first and then apply the 4% increase. So in order to apply that 4%, repeat. So this will print the marks of the student 1. So now I want to apply that 5% increase in his marks. So for that, what I need is, I need to write in student. For that, what I need is, now we have printed the marks of the first student. Now I need to apply that 5% increase in his marks. So for that, I'm going to type in student underscore 1, that is nothing but the instance, and then dot the name of the method, that is apply underscore raise, and the parenthesis. Now go ahead and print the final marks. So for that, again, I'm going to type one more print statement, the name dot marks. Let me just comment the other two print statements. All right, so let us go ahead and execute this. So earlier Neil's percentage was 60%, but after 5% increase in 1 year, which is pretty bad, it has come to 63%. So now let us do that with the student underscore 2 as well. So for that, what I need to do is I need to just type in here student underscore 2, same student underscore 2, and over here as well. Now let us see what happens with the studious student in our class. So he scored 90% earlier. Now with 5% increase in 1 year, he has come up to 94%. So yeah, keep up the good work, Hemant. Now I'm going to show you the dictionary of the second student, that is std underscore 2. So for that, what I need to do is I need to just write in print the name std underscore 2 dot dict. All right, so let us go ahead and execute this and see what happens. So this will give me all the key value pairs that I'm talking about. So first name, this is the key, this is the value for that. Similarly last, and this is the value for that last key. This is the key again, and this is the value. Similarly, when we talk about email address. One thing to notice here, guys, is that nowhere it is written the pers_rise is equals to 1.05. That is nothing but the class variable. You cannot see it in the whole dictionary of that particular object. So basically when we access that pers_rise from our instances, they don't actually have that attribute. They're accessing the class's pers_rise attribute. So I hope you all are clear with what I'm trying to say here is, so in the namespace of this object, you won't find that particular class variable, but it is actually taking that attribute from the class. Similarly, if I print this dictionary for my class that is nothing but student, what I'll get is print student dot dict, and let us see what happens when we run this. Yep, so it has Hemant Sharma's marks, email ID, plus it has a pers_rise that we are talking about. That is nothing but the class variable. So I hope you have understood what our class is and how to create an object for a class, and we have actually seen how to define method inside the class. We have seen what exactly are class variables. So all those concepts I hope you all are clear with. So I'll move forward and explain you what is inheritance. So what is inheritance? Just like it sounds, inheritance allows us to inherit attributes and methods from the base class. This is useful as we can create subclasses and get all the functionality from our parent class. And then we can override and add new functionalities without affecting the parent class in any way. So let us take the example that is there in front of your screen. So we have a vehicle that is nothing but a superclass. So there are multiple kinds of vehicles. We have trucks, we have cars, we have bikes. And among those types as well, we have subtypes. For example, in bikes, we have pedal bikes, we have motorbikes. When we talk about cars, we have pickup cars, super cool sports cars, convertibles, and vans. Now, and the same goes for trucks as well. We have medium-sized trucks and we have heavy-sized trucks. Now, one thing to notice here is, when we talk about vehicles, in Python, we can create a class named vehicles with methods for accelerate, brake, etc. Now, that same method or the same functionality can be actually inherited by your base classes. What are the base classes? Base classes are cars, bikes, and trucks. Because obviously all the three types of vehicles will have accelerator, brake, and some other common functionalities, even wheels. And when you are in India, you actually need brakes more than accelerator. So yeah, basically what I'm saying is, so there are certain functionalities which will be common for trucks, cars, and bikes. So instead of writing the code or the method again for each of these classes, it can actually go on and inherit that functionality from the superclass that is nothing but vehicle. So I hope you have understood the concept of inheritance. So what I'm going to do is I am going to show you practically how to inherit certain functionalities from your base class. So now if I want to create some classes like type of students. So I want to create studious students and I want to create dumb students. Now these could be good examples for subclasses since both studious and dumb students will have name, email address as well as marks. And these functionalities are there in the student class already. Instead of copying this code for our studious and dumb subclasses, we can just reuse the code by inheriting from the class that is nothing but student. So let us go ahead and execute this. So what I'm going to do is I'm going to come down here and and now over here. So I'll just go down till here and now I'm going to create a class for dumb students. So I'm going to name my class as dumb. And over here I'm going to write the name of the class from which I'm going to inherit certain functionalities, which in this case is student. Now give a colon here and let me just pass it for right now. Now what I'm going to do is I'm going to change the name of the class, that is student. Instead of that I'm going to write in dumb. So whatever functionalities were there in the base class that is student will be available in this dumb class. So now what I'm going to do is I'm going to print in, say, std_1 dot email. So the dumb student, that is Neil, his email address will be printed. Let us go ahead and execute this. Yup, so the email address of Neil is neil.verma@school.com. So as you can see that in my dump class, I have not defined any method nor any attribute. What it is doing, it is actually inheriting from the base class, that is student. So the dump student Neil, all of his details are actually available in the class dump as well. So basically when we instantiate our dump students, it first looked at our dump class for init method, but it won't find it in that class because it is currently empty. Now it will look at other places on the basis of a method resolution order. Let me help you visualize that. I know a lot of tricky terms, a lot of technical terms. So let me help you visualize that. So what I'm going to do is I'm going to throw in one more print statement and I'm going to write in help, and in between I'll write in dump. Alright, so let us go ahead and execute this. Let me just move up a little bit. Yep. So this is the method resolution order that I was talking about. Now, whenever I instantiate my dump students, it will first look at the dump class for the init method. That is here in the method resolution order at the top. After that, it look at the base class of this dump class, that is student. Even if it doesn't find over there, then it will actually look in this object class. So every class in Python inherits from this object class. So I hope method resolution order is clear to you. Let me just repeat it once more. So what happens when I actually instantiate the dump students, it will first look at the dump class for the init method, but it won't find it there. So it will first look at the dump class, then it will look at the student class, that is nothing but the base class for the dump students or the dump class, and then finally it will look in the object class. Now what if I want to change the pers_rise for the dump student to 10%? He's working hard. Say suppose Neil has started working hard and he's getting good marks. So basically his marks are increasing at 10%, say at the rate of 10%. So let me show you how you can do that. Now what you need to do is in the class that we have defined as dump, just write the pers_rise equal to 10%. Let me show you how to do that. I'll just remove this pass and I'm going to write here as pers_rise equal to 1.10. That is nothing but 10%. Alright, so now over here instead of email, let me just print his marks so that you'll get to know how much he's improving. And let me just remove this print statement. So now let me just print it. So for that I'll type print std_1 dot pers_rise. So let's go ahead and execute this. Yep, as you can see that it has updated the percentage increase in marks from 5% to 10%. Good job, Neil. Now let me show you if I change this class name from dump to the base class, that is student, over where, and in this class the pers_rise is still at 5%. So let me show you. I'll go ahead and run this. Yep, so it is still 1.05. So as you can see that particular functionality or that particular class variable, we have changed it in the dump class only. Alright. So now what does this prove? This proves that whatever changes that we have made in the dump class does not actually affect the class variables that was present in the base class, that was student. Now if I want to add one more attribute, say a programming language in which the student is master, I'm going to do that with the help of init method, but it doesn't exist in our parent class. So how will I do that? I can copy the entire student logic and do that, but it will increase the code size and we want it to be more manageable. So let me show you what I'm going to do now. Now below this class variable, I'm going to define one more init function, and let me show you how to do that. In itself, and obviously I want the first name, the last name, marks, and plus I want programming language. So for that I'll just type prog_lang. Now what I'm going to do is I'm going to actually inherit init method that was there in my base class. So I'm not going to write the entire logic for first name, last name and marks. For that I'm going to inherit from the base class. So I'm going to only write the logic for my programming language. So for that what I need to do is I need to type in super open close parenthesis dot init first, last, and marks. Alright, and now I'm going to define the programming language. So for that I'll type self dot prog underscore lang equal to prog underscore lang. Alright, now over here what I'm going to do is I'm going to add one more attribute, and let us say he's a master in Python. Yep, let's keep it as Python. So now what I'm going to do is, instead of the student class, I'm going to type in the dump class from which I'm inheriting the student's functionalities. Now I'm going to print this programming language. For that I'll type print std underscore 1 dot prog underscore lang. Go ahead and execute this so you can see Python is available here. So basically with just a little bit of code I have made those changes. How I did that, I just inherited whatever the functionalities were there in my base class to my parent class, that was dump, and my base class was student. Now let us understand what are abstract classes. So what I mean by abstract class is that these classes cannot be instantiated, or you can say that you cannot create the objects or instance for these classes. But it can only be used for inheriting certain functionalities, and you can call it as a base class. So you can call it as base class, you can inherit certain functionalities, but at the same time you cannot create the instances or the objects of this particular class, that is abstract class. Let us understand with the diagram here in front of you. So this is the abstract class. So when I try to create an object of this abstract class, Python won't allow me to do that. So when I use this abstract class, in order to provide certain functionalities to a base class, or you can say to a child class, it can do that. And with that class you can create objects. So you cannot directly create objects, but you need to inherit the functionalities to a base class, and then you need to create objects. So I hope I'm clear with what are abstract classes. So let us go ahead and see one example for abstract class. Now in order to show you an example for this abstract class, what I'm going to do is I'm going to first remove all this code that we have written till now. Now I need to import certain methods. So for that I'll type import ABC, that is abstract base class, import ABC, comma, abstract method. Alright, so now I'm going to create a class, and let us name it as employee, and over here write abstract base class. Now go down and write @abstract method. So this abstract method is nothing but a decoration. So now after this I am going to define one method that I'm going to name it as calculate salary. So it has self, comma, one more attribute, we can call it as salary or sal. Now just pass it. I'm going to create one more class, and I'm going to name it as developer. This developer is actually going to inherit certain functionalities from the employee class. So I'm going to write the name of the base class, that is employee, give a colon. So now I'm going to define a method that is calculate salary from my base class that has attribute sal, and over here I'm going to write the final salary, which is equal to salary and plus this 10% hike in the salary. So I'll just write multiplied by 1.10, and now return the final salary. So this is done now. Now what I'm going to do is I'm going to type in here, say employee underscore 1, which is of the type developer, open and close parenthesis. Now print the salary for this employee underscore 1. So I'll just write emp underscore 1 calculate salary, and whatever base amount is, so I'll just write it as 10,000, and it is going to increase it by 10%. Alright, so go ahead and execute this. So yep, it has become 11,000, that is 10% increase in the salary. Now what I'm trying to show you here is, if you actually go on and make an object of this class employee, it will show you an error. It will say cannot instantiate. Let me just show you if I make an object for this particular class, what will happen. So let me just go and comment this print statement. And now what I'm going to do is I'm going to just type in, say, employee underscore 2, which is equal to the type employee. Now I'm going to define the variable or the attributes for this. So I'm just going to type in employee underscore 2 dot salary, which is equal to, say, 1000. And now I'm going to print it. So for that I'll type underscore 2 dot sal. Now let's go ahead and run this and see what happens. So it says can't instantiate abstract class employee with abstract method calculates salary. So basically what I'm saying is you cannot instantiate or you cannot create the instance of an abstract class. You can inherit certain functionalities from that abstract class to a base class or to a child class, and then from that child class you can create objects. So I hope I'm clear with this abstract class concept. Let me just go ahead and delete all this. Now over here there's one more important thing that you need to notice. When I'm using an abstract class or if I'm inheriting the abstract class, it is very important that you first use this method that is defined in that abstract class, that is calculate underscore salary. So what if I change this name and I keep it as, say, salary, or what if I change this name and I keep it as sal underscore 1. Now again, if I run this class, it will say can't instantiate abstract class developer with abstract method calculate salary. So what I'm saying is you need to use that particular method which has been defined in the abstract class at least once. So now you can actually write whatever methods you want to do, but first you need to make sure that you have actually used that method or you have defined that method in your base class, or you can say the child class. I can give you an example as well. Now, what if I define one more method and I'm going to name it as position underscore 1 and give an attribute to it as position. And now what I'm going to do is I'm going to type in self dot position equal to position. And finally return this position. So return position. Now I can actually print this position. So for that I'm going to type in print employee underscore 1 dot position underscore 1 open and close parenthesis, and whatever position he has, maybe he's a web developer. Go ahead, execute this, and yep, you can see that web developer here. So basically what I'm saying is you can actually use whatever methods you want in your base class or in your child class, but you need to first make sure that whatever method that you are inheriting from your abstract base class are using it first, like calculate underscore salary. So by this we come to the end of today's session. Let me just give you a brief summary of what we have discussed till now. So first we saw what basically are classes and objects. And then we saw how to create a class in Python. We saw the syntax. We created a class that is student, and we created multiple objects as well. The std underscore 1, std underscore 2. And then we saw inheritance, that how we can actually inherit certain functionalities from the base class to the child class. Then we saw what exactly are abstract classes in Python. Thank you and happy learning.